Hopefully you've all had a chance to get the work turned in for week 2. I realize that using Excel can be challenging, as you'll see in this video. I've created the examples from tables 1-7 and 1-8 to make all the figures shown in the book. It really wasn't that hard, but it did take a little time to do. Along the way I learned some shortcuts like copying scatter charts and changing data selection values. Later this week I'll post the Excel example of how the author created the graphs in the last part of this chapter. Here are some of the things I'd like to point out now. Worksheet table 1-7 from page 46 shown here This is a worksheet tab, and I used the same actual production and energy use data from the textbook. I then inserted the scatter chart, just like Professor Fastfingers from last week's video. I edited that scatter chart to include a name and n equals 27. That corresponds with the 27 markers for the months of data that were being used. Notice that the cells for the chart are highlighted when the chart is clicked on. I made a copy of worksheet table 1-7 and I renamed it as figure 1-20 baseline. This was the hypothetical 12 months of consistent performance data mentioned on page 48. That's when the convenience of Excel became apparent. By right-clicking on the scatter chart from table 1-7, I was able to use the Select Data command and choose only the first 12 months of data. When I finished that command, the slope and the intercept were automatically recalculated. Then all I had to do was delete the extra months of data from the original table and add the regression analysis using the data analysis button. I made yet another copy of table 1-7 and renamed it to be table 1-8. To this I added the 3 extra columns for predicted process energy, variance minus actual predicted, and Q sum. All of this in millions of BTUs. The explanations in the book told me what math needed to be performed, which includes the predicted process energy cell E4. This is where I used the slope of 2.078 and multiplied it by the production pounds, then added the intercept value of the energy. In this case, 64,966. I placed that formula shown here in the predicted process energy column just for convenience. After that calculation was done, I used the pull down command. Notice as I bring the cursor close, it's a outlined plus and it turns into a dark solid plus. Then I clicked and pulled it down to perform the calculations for the rest of the column. Cell F4 is the variance between the predicted and actual energy use, or the contents of D4 minus the contents of E4. So I've selected the cell here and notice the formula shows up here in the formula box, formula block. Cell F4 was also pulled down to calculate the rest of the column. Since G4, the Q-sum, was the first line of Q-sum data, it is the same value as F4, but cell G5 needed to have the contents of F5 added to the Q-sum value of G4 shown here. And again, the pull-down feature was used to finish the calculations for the column. The purpose of all of these actions were to show that the Q-sum value in cell G30 of table 1-8 resulted in the savings of nearly 130,000 million BTUs of energy compared to that same cell in table 1-7 before the predictions and the corrections were made. Now, I'm not going to ask you to recreate any of those charts, but give it a try if you'd like. I will show you that I also created scatter charts for figures 1-23 through 1-24 to show you that it can be done, just like in the book. Figure 1-23 on table 1-8 used the data from months 18 through 24 to create the slope and the intercept shown here. And this was used as a goal or a target performance model as discussed in the book. So I added two more columns to our table, the target process energy and the variance actual minus target. This was used to create table 1-10 as shown in the book. All of this then illustrated how we could use this data to create a control chart and give us some control variables as shown here in figure 1-24 of the reading. So happy computing. I hope you have as much fun with Excel as I have, maybe even more.